center of gravity, right? Along the longitudinal axis, either what I was saying, either the inertial forces, the D'Alembert forces are acting, or the tractive forces at the ground are acting. The tractive forces at the ground, the tractive forces at the ground with the tail height of center of gravity. Tractive forces. Whenever I talk about the longitudinal, it is about the tractive forces or the inertial forces. Now, inertial forces are acting on the same position, so we won't consider it. So we will be considering the tractive forces at the ground, with the height of center of gravity. With the height of center of gravity. Now, pitching moment, it means the pitching moments can be reduced. The height of center of gravity will be reduced, right? The pitching moment can be reduced if the wheelbase will be increased. Similarly, for the case of rolling, right? If the track width is increased, the rolling can be reduced. If the center of gravity height is reduced, the rolling will be reduced. You got this thing? Okay. Now, when we talk about the yaw movement, the steering movement along the transverse axis. Again, when we talk about the transverse axis, it's either because of the longitudinal or the lateral axis, right? Longitudinal or the lateral axis. How? Let's talk about the lateral axis first, right? Sorry. Now, this is my transverse axis, right? This is my transverse axis. All the cornering forces that are acting, right? This is the height of center of gravity. See the force. All the cornering forces that are actually acting on the tire, the centripetal forces, right? The centripetal forces. So they will try to create the movement along it. So whenever you provide a directional input, let's go. I take the transverse axis towards the tire center. This is my tire. Where do I draw it? Okay, let's draw it here first. This is my transverse axis. I take my tire to the transverse axis. I take my transverse axis towards the tire. Now, behind the tire, I've got my steering arm. At the steering arm, providing the translatory force, and this force, the length of the steering arm, right? Length of the steering arm is the trail to provide the yaw effect. And this, see, the translatory motion is like this or like this. With the tie rod, I am just pulling it or pushing it. With the tie rod, either I am pushing it or I am pulling it, pulling it. Right? The length of the steering arm length. So this is my transverse axis at the tire. This is my tire transverse axis. See here, I have got my steering arm. I am pushing it here, pushing it there. At which trail? This trail. Yes, this force that is acting on the steering arm is the lateral force, right? Is the lateral force provided by me, right? How much force am I going to provide? I'm going to provide the force that can compensate with the weight on that tire, or the normal reaction on the tire, considering the caster, camber, all the other geometries, right? All the other trails. Okay, steering arm length. And what about the longitudinal forces, tractive forces that are occurring? Now again, this is my axis. This is our, yes, what is this? This is our tractive force, right? Now tractive force, and this is our track width. Along this movement, it is trying to create the movement. Now from where is this tractive force occurring? From the rear track width. Now you can see the motion. This is my vehicle center axis, right? Transverse axis. If the rear track width is higher in comparison to the front track width, what will happen? The effective movement of the rear tire is in this direction. The front tire is in the inner direction. This is the outer direction, right? Okay. And what if the frontal track width is wider? The rear track width is inner. It would be outer. It would be inner. Inside. It would be inside. the resultant of the forces of the torque or of the tractive forces produced by the rear axle and the front axle would be different. So the behavior of the tire in the rear axle, when the rear axle is wider or when the front axle is narrower, in comparison to the case of the opposite dimensions, it would be completely different. You got this thing? You got this thing, guys? Now, just look into this figure. Look into this figure. This is the most crucial thing that should have to be considered while designing the steering. Right? Once you are aware of all the forces and their reactions, it gets very easy. Now, there is one more thing. Along the lateral axis, your tire is also rotating. Your tire is also rotating. Now, what causes this thing? Your friction or the tractive or the longitudinal force. Right? Where is it? Longitudinal force. Oh, sorry, lateral axis, longitudinal force, center of gravity, height. This is one case for the pitching. Right? This is one case for the pitching. But what about the rolling? We haven't considered this thing. The rolling occurs because of, there is one more thing, that is rolling. Rolling also occurs because of the longitude, or I just don't write it here. Right? Make a separate column for lateral axis. I am making a separate column for lateral axis, where I will consider rolling of the tire, rolling of tire or wheel, right? Rolling of tire or wheel that occurs because of longitudinal axis. Longitudinal axis, the force acting along the longitudinal axis, right? That is the tractive force. That is the tractive force. And what is going to be trail? Trail is going to be the radius of tire. Trail is going to be the radius of tire. You got my point? Radius of tires, right? So if I take my lateral axis, this is the lateral axis, and take my lateral axis, bringing it to the tire radius, right? This is rotating, completely rotating, right? This is rotating because of the longitudinal axis that is occurring between the tire contact patch and the road surface, between the tire and the road contact patch. Now there is one more thing. Okay, here I have to finish it up. There is one more thing. Yes. What is that thing? Okay, rolling occurs. Yep. There is one more thing. So if I take the longitudinal axis, along the longitudinal axis, this is the motion, this is the arm, right? So if I take my longitudinal axis to the tire, the camber change, yes, the dynamic camber change. So where is it? If I take the longitudinal axis again, dynamic camber. So this is the resultant, rolling. This is the resultant of dynamic camber change. I'm just writing down separately for the better understanding. Camber. Force axis. Now force axis. What is going to be the force axis for the dynamic camber change? The normal force. Where is it? Longitudinal axis. Yes. The transverse. I can write it down. The transverse axis. The normal force that is occurring. This normal force is making your tire go for the camber in or camber out. Camber in or camber out. Camber in or camber out. Positive movement or the negative movement on the longitudinal axis that is being translated to the tire. Right, to the tire. Okay, and what is the trail? What is that trail? Trail is the distance between the tire center contact patch. Distance between tire center contact patch and immediate hinge point. Or I could say steering axis. Write it down. I'll write it here. Steering axis or kingpin axis. Distance between the tire center contact patch and the kingpin axis. You got this thing, guys? You got this thing? So now this thing that we have discussed here is the most important thing. I will write the force here, the movements here, alright, for the separation between these two. I'll just rub it here. You already got this thing. You got this thing? Now this is the most important thing. Like it gets quite difficult for understanding this thing because it's not so explicitly available on the internet research papers or in the textbooks. right? Once you get this clarity about the action of the forces that are acting on the vehicle, right? The action of the forces, like all these forces are going to create some of the movements in the vehicle. Once you get this understanding clearly, you can solve any equation, right? And I already told you, you can never get the exact values for the things. But what you can get actually, you can get to know about the relationship between these different components, or between different components. Okay. Now I could assume, and I am assuming that you got this diagram, you got this thing completely. You got this thing? Right. Kingpin inclination. Yes, I talked about the kingpin inclination. Or even the longitudinal axis has been translated towards the tire. Your camber change is occurring. Camber change is occurring because of the distance of the immediate hinge point and the kingpin. That is camber. Right? And now, even when the steering arm, we were calculating about the steering arm, when your lateral axis has been shifted towards the tire, your tire is rolling, and when you provide the steering input to it, that is transverse axis. If I take my transverse axis on the tire, and when it provides the yaw effect, it's because of the distance or the this length of the steering arm. It happens because of the length of the steering arm, or offset of your rack and pinion, or your whatever the things that you have used, whatever the assembly that you have used for the steering, right? Tire center, distance between the tire center and the point of force, point of translatory force, lateral force that is acting on the vehicle. Right? Now all these coordinating forces are acting at the center of gravity location. All these coordinating forces are acting at the center of gravity location. Again, there are the lateral forces. You can calculate its behavior. The trail would be the center of gravity height. Right? Now slipping forces, again you can calculate it. When you talk about the slipping forces, the trail would be the radius of the tire. You got these things? Right? Okay, so when the inertial loads transfer, whenever you apply the brake or whenever you accelerate your vehicle, it happens at the center of gravity location along the course of wheelbase. We can calculate all these things. Once you get this formulation, you can make as many iterations as possible, but it is very important to establish these relations. Okay guys. Now one of the biggest questions that most of the people used to ask me, or most of the students or people are confused about, like most of the people, most of the motorsport enthusiasts and all the teams, basically I could say, all these people are so much confused about this and how to decide the caster or camber and KPI, right? And what we end up with the iterations, and with the iterations, yeah, definitely with the past experiences and the iterations, we can improve our performance. What is the theory behind it? Let's just talk about the theory behind it. Now, all the forces that we have discussed, all the action that we have discussed, it covers the caster, it covers the camber, and it covers the toe also. Now, it needs your visualization to find it. I talked about the longitudinal plane, top-down plane. I talked about the side plane. From the side plane, you are going to see the caster. From the up-down plane, you will be seeing the toe. From the front plane, your lateral plane, you will be seeing your camber. Okay, so now when I talk about the camber, camber is the inclination of the tire, towards the lateral axis, towards or away from the lateral axis, that occurs because of this part, right? Or now, see, this happens. This is not only going to happen because of this. Now, this is the reaction along the longitudinal axis. Now, you already know this thing. If this is a reaction along the longitudinal axis, it happens because of the normal force and also happens because of the coordinating force. It happens because of the transverse force, but also happens because of the lateral force. Now, lateral force. This happens. This is the longitudinal axis. Lateral force is acting. This force is acting. This force is moving up, and this distance, because of this distance, this is happening. And now this different distance here is the hinge point, the kingpin, the hinge points, the steering axis, right? And when I talk about the lateral axis, how is it going to provide the camber change? How is it going to provide the camber change? When I talk about the lateral forces, how is it going to provide the camber change? Guys, let me just check my mobile. I got a beep here. Okay, nothing serious. Video is still on. I got like maybe because of the memory or something, the video got stopped. Transversal. Okay, let's just select it. Now, because of the lateral axes that are occurring here, because of the lateral axes that are occurring here, how is it going to provide the trail? Now, this is my longitudinal axis. Sorry, this is my longitudinal axis. These are the lateral forces that are acting on it. These are the lateral forces that are acting on my longitudinal axis. And what is going to be the course of motion? This is the course of motion. How is it going to provide? Only if I am having the trail, Now, whenever this is happening and your tire is having this camber change, your tire is going to have a camber change because of the radius of tire. So whenever you will corner your vehicle, this will also try to create the camber change in your vehicle. This will also try to create the camber change in your vehicle. So now, how is it going to provide the camber change? If the resultant of this, like whatever the forces that are acting, this is the static position. Now, this is the static loading. So whenever I turned my wheel, I took the change. So what will happen? This transverse force will change, right? If my vehicle is taking the right turn, towards the right, if it's taking the turn, right? The complete weight is going to be transferred here. The inertial forces will try to put you in this direction. Now the lateral forces that are acting here, your wheel will try to move in this direction. The lateral forces that are acting here, the first force that will act here is the slipping force produced by the tire. That is an interim property of the vehicle. The second force, the lateral force that I am talking about, is the D'Alembert force. The inertial force. The change in load, right? Change in load that is occurring in the vehicle. Now these are the transverse forces that are acting. These are the lateral forces. These are some of the lateral forces that are acting on your tire to cause the camber change. And you know its course. The one course is this, the other course will be in this direction. Whatever is more, you can get the value for the same. So what could be the maximum and minimum value for the camber? So when I talk about the camber, the maximum value of camber that you can provide to your tire is the edge, at the outer edge, the extreme edge of the vehicle, right? So the minimum value is 0, the maximum could be this part, right? When your wheel is aligned at the extreme fiber. Take it here, not there, right? Aligned at this from here. From here it will happen, or maybe at here, this direction will happen. Whatever the case, right? So your tire width decides the maximum camber angle as well as the distance of the tire center contact patch from the immediate hinge point. These two factors will decide what is going to be the angle of camber, right? What could be the minimum and maximum value of camber angle? Now we all know our wheel is rolling along the lateral axis. So whenever you will corner, that corner will occur because of this steering axis. See, this is the steering axis now. It could be this, it could be anything, right? Along the steering axis. So what do we suggest? Like whenever you are taking a corner, this is my longitudinal axis. Transverse axis, Baba. Transverse axis. This is my transverse axis. Transverse axis is perpendicular to the longitudinal axis, right? It's perpendicular to the longitudinal axis. But when we talk about our steering axis, or particularly if I say when I talk about the caster angle, what I am talking about, the caster angle, the tire movement, whenever you are going to provide the steering input, the tire movement is occurring on the on the transverse axis, but your steering axis is inclined. Your caster, this is the caster, right? So actually all the forces are acting and it should have to move on this direction,